In this video, we look at the equation of a tangent and normal to the curve at a point. Now, if we are to consider a curve which is defined by a function of x, say f of x, we can determine the derivative of this function, say f prime, which is also known as the gradient function, and with the gradient function, the gradient of the curve at any point can be found. Now, if we are to consider any point of interest, say the point A, with coordinates x subscript 1 and y subscript 1, then the line that touches the curve at the point A, as shown in the diagram, is known as the tangent to the curve at the point A, whose gradient will be the same as the gradient of the curve at the point of interest A. So with this information, we can determine the equation of the tangent to the curve at a particular point. Now, the normal is any straight line drawn perpendicular to the tangent. And so if the normal is to pass through the same point of interest, then the equation of the normal can also be determined. So this line will be the tangent to the curve at the point A, and this one will be the normal, which always stands perpendicular to the tangent. So if m subscript 1 is the gradient of the tangent, and m subscript 2 is considered to be the gradient of the normal, and since these two lines stand perpendicular to each other, the product of their gradients is given as -1. So we can go ahead with this information to determine the equation of the tangent and normal to the curve at any point. So let's look at one or two exercises. So in an exercise, let's find the equation of the tangent and normal to this curve at the point 1, 3. And to do so is first to determine the derivative of this function, also known as the gradient function. So we are given the derivative of this function is given by so at the point, the gradient of this curve at this point will be given by substituting the value of x as 1 in the gradient function. And when we simplify, we get 4. So from the question, we are supposed to find the gradient. So the gradient of this function at this point is 4. Now, if we are to determine the equation of the tangent at the point, would mean that straight line that touches the curve at the point 1, 3. So we're going to apply the formula which is used to determine the gradient of the straight line. So our point of interest, x subscript 1, y subscript 1 is 1, 3. Our gradient is 4. So when we do the substitution, we're going to have the equation of the tangent as so this is the equation of the tangent to the curve at the point 1, 3. Now, if we are to consider m1 as the gradient of the tangent and m2 as the gradient of the normal, then since the tangent and the normal are perpendicular to each other, it will mean that is to say the product of the gradient of the tangent and the normal is -1. So with this, m2 is equal to negative 1 over 4. So having the same point of reference but a different gradient, the equation of the normal is going to be and if we are to do substitution of our point of interest, we're going to have and when we simplify, we're going to have this. Which means the equation of the normal will be given by, and when we multiply through by 4, we're going to have the equation of the normal also expressed as, and if we are to reposition this term, we're going to have the equation of the normal as, so this is the equation of the tangent, and that is the equation of the normal. Now, let's look at this question too that requires of us to determine the equation of the tangent for the function f of x, x squared plus 1 all cubed at the point where x is equal to minus 2. Now, let's find the coordinates of this point. Let's substitute x is equal to minus 2 in this expression. We're going to get so our point of interest, say A, is minus 2, 125. Now, our function is of the form to determine the derivative of such a function, we need to apply the chain rule method of differentiation. And by the chain rule, its derivative is given by, we bring down the exponent as a coefficient, we maintain what is in the bracket, we subtract 1 from the exponent, then we differentiate what is in the bracket. So our derivative using the chain rule method of differentiation, we're going to bring this exponent down as a coefficient, we maintain what is in the bracket, we subtract 1 from the exponent, then we differentiate what is in the bracket, and when we differentiate what is in the bracket, we get 2x. So if we are to simplify, our derivative for the function is given by so this is our derivative. The gradient of the function at the point negative 2, we're going to have so then we're going to have the gradient of the function at the point negative 2 as, so we're going to have negative 300. So this is the gradient of the curve at the point negative 2. And that happens also to be the gradient of the tangent at that point. And so to determine the equation of the tangent, we're going to apply the formula where m is the gradient of the tangent and m is given by negative 300, and our point of interest is given by negative 2, 125. So if we are to do the substitution into this equation, we're going to have if we are to simplify further, we're going to have the equation of the tangent as So the equation of our tangent is so sometimes the function can be expressed in this form, which would require that we apply the chain rule method of differentiation to determine its gradient function. Then we can go ahead and determine the gradient of the function at the given point of interest. And we should also take note that when we have an expression or a function in this form, we bring the exponent down as a coefficient, we maintain what is in the bracket, we subtract 1 from the exponent and differentiate what is in the bracket. So this is the answer. This is the equation of the tangent. Now, for this question, we have an implicit function. So here we are expected to determine the gradient of the curve at the point A, -2, 3, and also to find the equation of the tangent and normal to the curve at point A. So we need to determine the derivative of this implicit function. So we are given and this would involve differentiating each term separately. Now, let us recall that when we have a function of the form y is equal to uv, now the derivative of that function is given by so when we have an expression which is a product of two factors, as we have over here, we're going to maintain the first factor, differentiate the second factor, then we maintain the second factor, then we differentiate the first factor. So with this implicit function, it will mean that we differentiate each term separately. Now, in differentiating this term, we will be guided by this formula over here. So we maintain x squared and differentiate y with respect to x. We're going to get, then we maintain the y and differentiate the x squared, we're going to get 2x. Then we come to this term. We maintain 3x, differentiate y, then we maintain y and differentiate 3x. Then we differentiate this, we're going to get dy dx, then we differentiate a constant is 0, then we differentiate this, we have 0 over here. So let's factorize out dy dx out, we're going to get x squared plus 1 plus 2xy plus 3y is equal to 0. And if we are to simplify, dy dx is equal to negative which can be rewritten as so this is the gradient function, and we are supposed to determine the gradient of the curve at the point A, -2, 3. So let's substitute the values of x and y in this to determine the gradient of the function. So at the point A, dy dx is equal to y is 3, that is 2 -2 squared so we're going to have, so here is 4, -6 plus 1, So we're going to get -1. So at this point, the gradient is -3. So gradient of tangent is -3. This would mean gradient of normal is 1/3. So at our point of interest, x subscript 1 and y subscript 1, giving us -2 and 3, and when we consider the gradient of the tangent as m subscript 1 and the gradient of the normal as m subscript 2, the equation of the tangent will be given by so we're going to have m1 is -3, so the equation of the tangent so we're going to have this. So that is the equation of the tangent, and the equation of the normal will be given by so using the same point of interest, we're going to have so simplifying, so the equation of the normal is, or we can rewrite it as, so that is the equation of the tangent, and here the equation of the normal. So that is the end of my video. Thank you very much for watching, but keep watching.